Good afternoon, sir.
Good afternoon, sir.
Good afternoon,
Yeah,
sir.
good afternoon. Yeah,
Good afternoon, sir.
yeah, good afternoon. Good afternoon. I think some other people are still to join, no? Okay.
Good
Yes,
afternoon,
sir.
sir.
Yeah, good afternoon. Good afternoon. How are you all, everyone? Fine?
Yes, sir.
Fine, sir.
Absolutely fine.
Yours? Yes, sir.
Okay,
Fine, sir.
okay, okay, very good. Yeah. So, anyone, any doubts regarding what we did last time?
No, no, sir.
Okay, okay. Like in the last lecture, we were doing that median, no? So before that, we had seen the mean, weighted mean, and median. We had seen for ungrouped data. Okay. So, so once everyone joins, I'll start with the median for group data. Okay. I'll wait another couple of minutes so that everyone can join. All of you had earlier two lectures before this today also.
Yes, sir.
Yes, sir.
Okay, okay, okay. So then after this, like Wednesday morning we'll have the small test. As I said, 9:30 we can have that. So it will be very small, very easy one. So I'll by Tuesday I'll send you the link for that. Okay.
Okay, sir.
Yeah. It's going to be very simple. Even while sleeping also you can answer. It's so easy. Okay. Yeah. So it will be based on whatever topics we finished till today. Okay. For the foundation course. Has ma'am told anything about that after uh, like after the foundation course tests, like any subsequent dates? Has Vatsala ma'am given anything?
So the test for that she's given us 27th and 28th, and then she told us that on 29th, the normal lectures would commence.
Okay, okay, okay. But there's no timetable. Acha, timetable will be given maybe later on, no? I think. Okay,
Yes,
Yes,
sir.
sir.
Yes, sir.
okay, 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 okay. Okay, I'll just share that file which you were doing last time. 1 minute. Okay, just a minute. I'll just share this. Okay, I'm sharing this file. Uh, just it will take I think a minute to load this. Uh, are you all able to see this file here?
No, sir.
No, sir.
No, sir, not
Yes,
yet.
sir. Yes,
Uh,
Yes,
yes.
now it is.
Yes, sir.
Yeah,
Okay,
it's
okay,
visible now, sir.
okay, okay. Sometimes it takes a little time to load. So now, is everyone able to see this here?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, okay. So in yesterday's lecture, we had seen this median, like how we find out when it's a ungrouped data. And the last example we had seen was when uh, there are repeating values. So frequencies were given in that. Okay, so the first thing we do in that was we had arranged the x values in ascending order and written the corresponding frequencies. Then we found out the CF values, cumulative frequencies. Okay, and like in the previous example, if you see here, uh, one second. In that case, the last CF value was 22, and so the total number of terms was 22 there, which was an even number. So we saw that there were two middle terms. Okay, that is 11th and 12th term, and based on the CF column, we found out which are these two terms and took the average. Okay. Now, if I have a class interval data, then in that case, we don't have to worry about whether n is odd or even. Okay, that is one main difference between ungrouped data and group data. Okay, so in this case of class interval data, we'll just find out only the n by 2 term, irrespective of whether n is an odd number or even number. And then we'll use a particular formula and find out the exact value. So we'll see this example here, class intervals. Okay, classes are given and frequencies are given here. Now in this case, you can see classes are already in ascending order. So we don't have to arrange anything here. So we directly take the class intervals and frequencies and also find out the CF values. So all of you can just note down this problem here, these three columns, classes, frequencies and CF values. Okay, so we are given this data for class intervals, frequencies and CF. Okay, and CF we are finding out ourselves. Like first CF is 5, then 5 plus 12, 17, then 17 plus 10 is 27, 27 plus 4 is 31. Okay, so we got the values of the cumulative frequencies here. And the last CF value is 31. So which shows that the total number of terms is 31 here. N is 31. So now we don't have to see whether this is odd or even. Okay, we'll just directly find out n by 2. Okay, so that is a difference in the case of class intervals. We'll find out n by 2. So 31 by 2 is coming as 15.5. Okay, 15.5 term. So now based on the CF column, we have to find out that this 15.5 term will be in which interval. Okay, so all of you just see this and just tell me which interval will contain the 15.5 term.
10 to 20.
10 to 20.
Yeah, right. It will be there in the interval 10 to 20. Yeah, right. 10 to 20. Because see, the first CF value is 5, next one is 17. Okay, so we'll be looking at these two values. So our 15.5 term lies between the fifth term and the 17th term, between these two. So that's the reason that we'll take the interval as 10 to 20. Okay, the same logic which we used yesterday for ungrouped data. Okay, we have to find out that this particular term lies between which two CF values. So it lies between 5 and 17. And so the interval which we'll be taking here is 10 to 20. So our median will be somewhere within this range of 10 to 20. Okay, so that's the first thing, finding out which class interval will contain the value of the median. So the first step was we found out n, then we got n by 2 without bothering about whether n was odd or even. So n by 2 was 15.5 term and it lies in this interval 10 to 20. Okay. Now once we know the interval, now we'll be using a particular formula to find out the exact value of the median. Okay. So has everyone completed till here?
Yes,
Yes,
sir.
sir.
Yes.
Okay.
Yes, sir.
Okay, good. So now we'll see the formula which we can use here for getting the exact value of the median. So it's given by this. As you can see on the screen, I have highlighted here. Median is equal to L1 plus brackets, again a brackets, n by 2 minus CF into L2 minus L1 upon F. Okay, here L1 is separate. Okay, so L1 is a separate term plus then the next term is n by 2 minus CF multiplied by L2 minus L1 divided by F. Okay, so all of you can note down this first. So this is the formula we'll be using in the case of class interval data for getting the median. So in this case, what is L1 is the lower limit of the interval. Like we know that here, the interval that we are going to consider is 10 to 20. Okay, this interval will contain the value of the median. So lower limit is 10. So that will be our L1. L2 is the upper limit. That will be 20 here. Okay, so we have defined these two, lower limit and the upper limit, 10 and 20. Okay, n by 2 we have already got earlier as 15.5. Okay, now the other thing that we have is CF, cumulative frequency. Now here we have to see what CF value we have to take. Now for the interval 10 to 20, CF is 17, but we'll not take CF value as 17 here. We'll take CF in this case as 5, the previous one. Okay, now what's the reason for that is that if I take 17 as my CF, it means that we have already reached till the end of the interval 10 to 20. Okay, we have finished till the end of that. But actually our median is somewhere between 10 and 20. So that's the reason that we don't take CF as 17 here. We'll take the CF up to the previous interval. So in this case, the CF value will be taken as 5. Okay, not 17. Okay, so this is one thing we have to keep in mind, that the CF value will be taken up to the previous interval. Okay, so here we'll take the CF value as 5 because
Can you repeat that again?
yeah, I'll just repeat it again. See, we have to see what value of CF has to be taken. Now, if you see for the interval 10 to 20, in front of this, the CF value is shown as 17. But if I take CF as 17, it means that we have already reached till the end of this interval. But our median actually is somewhere between 10 and 20. So that's the reason that we don't take CF as 17. We'll take up to the previous one, that is 5. So always in this formula, the CF will be taken as the cumulative frequency up to the previous class interval. Okay, so here we'll take CF as 5. Okay, is it clear, everyone?
Yes, sir.
Yes, sir.
Okay, so
Yes, sir.
CF, yeah, okay, good. So CF will be taken as 5 here, and the value of F frequency will be taken as 12. That means for the interval 10 to 20, the frequency is 12, so that will be the value of F. Okay, so L1 and L2 are the lower and the upper limits of this interval. F is the frequency of the same interval, so F is 12, and CF we take as a cumulative frequency up to the previous interval. So here we'll take CF as 5. Okay, and n by 2 we have already got it as 15.5. So these values we'll put in this formula and we'll get the value of the median. Okay, is this clear, the meaning of all these terms?
Yes, sir.
Yes, sir.
Okay. So all of you can just put these values in this formula and see how much value you're getting here.
18.75.
Okay, 15.75. Okay, I'll just check that. 18.75, no?
Hmm.
Yeah. Okay, right. Median is coming as 18.75, right? Yeah. Okay. Others also, everyone can just see. Are you getting this value?
Yes, sir.
Yes, sir.
Okay. I'll wait a minute so that everyone can complete it till here. Okay, so we have to just be careful in substituting the values in that formula. As I said, L1 is separate, so 10 will be separate, and we'll just consider the other terms. N by 2 minus CF multiplied by L2 minus L1 and divided by F. Okay, so that particular answer, which will be finally adding up to 10, and so that will give us the final answer as 18.75. So this is the value of the median here. Okay, everyone has got it till here?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Okay. So that's how we get the median in the case of class interval data, group data here, where we don't have to see whether n number of terms is odd or even. Directly we just find out n by 2, and then from the CF column we'll have to see which interval will contain the median. So we take that interval, which will give us L1 and L2. CF we take up to the previous interval, but F is the frequency for that interval only, and then just substitute the values. So median we are getting as 18.75. So that means 50% of our data will be lesser than 18.75, and the remaining 50% is more than this. That is the meaning of the median here. Okay. So this is one of the again the important measures of center tendency, which can be used when our data has lot of fluctuations. When there are extreme values in the data, then the median can be used in place of the mean value. Okay. So we have seen so far the simple arithmetic mean, weighted mean, and now the median. Now, similar to the median, okay, another important measure we'll have is the mode. So there are other things also which I'll just come back to this later on. First, I'll just complete the mode, and then I'll come back to quartiles. Okay, so I just go to that, and then I'll come back to these points. Okay, so taking the mode first. Now mode, as we saw earlier, remember when we draw the histogram which we saw in the earlier lecture. Okay, the from the tallest bar, the tallest histogram bar, from that we were able to get the value of the mode graphically. So okay, now we'll see how we can calculate the mode numerically. So mode is that value which is the most common value, or the value which is the most often or most frequent value. Okay, that is called as a mode. Okay, and this can be used in cases where I have to find out which value is the most repeating value. Okay, like say if I have to find out which particular working hours is the most commonly observed among the employees, or what is a particular size of garments or shoes which is purchased by more number of people. Okay, so once this information is there, then the company can produce uh, more quantities of that particular size rather than producing equal quantities of all sizes. Okay, because we can come to know that this particular size is the most commonly observed. So more can be produced of that size rather than every other size. So that is one area where the mode can be useful. Okay, to find out the most common value. Or suppose I want to find out among various specializations, which specialization has the maximum students. So again, the most common value will be helping us to find that. Okay, or say among different regions, where which region is giving us the maximum sales. So like that, wherever you want to find out some value which is repeating the most often, then in that case the mode can be used. Okay, so again it has got a very restricted application, finding out the most common value. Okay, is this clear, everyone?
Sir.
Yes, sir.
Yes, sir.
Okay,
Yes,
okay,
sir.
okay, good. So, so if I have any data where values are given, like suppose I have these values here, 3, 4, 6, 4, 8, 4, and 10. So for getting the mode, I have to just see which value is coming the most often, or which is repeating the maximum. So we can see that the value 4 is coming the maximum times. So we say that mode is 4 here. Okay, so that's a very simple way in which mode can be got, the most common value. Or in case if you are given frequencies here, like if you see this example where x values and frequencies are given. So the value 5 is coming 6 times, 8 10 times, 10 is coming 3 times, and 4 2 times. Okay, so which is the most common value here?
8.
Yeah, right.
8.
Yeah, 8. Yeah, 8 is the most common value because its frequency is the maximum, 10. So here we'll say that the mode is 8. Okay, so that value of x which has got the highest frequency will be the mode here. So in this case, mode is 8. Okay, so as you've seen that it's a very very simple way in which we can find out the mode here. Now, in some examples, we may get more than one mode also. Okay, like if you see this example here, where we have given x values and frequencies. Okay, now here, if you see, the highest frequency is 10, but it is coming for three values, 5, 7, and 4. All three of them are coming the maximum number of times, 10 times. Okay, so in this case, we have three modes here, 5, 7, and 4. So we call this data as a multimodal data. Okay, this data is called as multimodal. Multimodal means that there are multiple modes here. Okay, there are more than one values which are acting as modes. Okay, like in this case, there were three modes, so we call it as multimodal. Okay, now the problem with this type of data is that we are not able to say which of them would be the proper representative of the data. Means which value would be a proper measure of central tendency, since there are many values which are acting as modes. Okay, so that's a limitation here. So in such a type of data where there are multiple modes, okay, it's better to use some other measure of central tendency like the mean or the median. Okay, because in this case we are not able to see which one will be the best representative here because there are multiple modes. Okay, clear? So that's a limitation of the mode, that first of all it has a limited application of having only the most common value, and if the data becomes multimodal, then we are not able to say which of them would be the most appropriate measure of central tendency. Okay, so in this case we say that there are three modes, 5, 7, and 4. Sometimes it may happen that there may be no repeating value. So then in that case, finding out the mode uh, becomes difficult in that. Okay, we can't say which is the mode because if there is no repeating value. Okay, like suppose all values are coming only once, or if every value is coming two times, then we can't say what is the mode in that. So in case if you want to find out the mode in that case, we'll have to find out using the mean and the median. Okay, so that's another formula we'll see later on, how we can find out the mode in case if there is no particular value which is repeating more often than the others. Okay, is this clear, everyone?
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
okay,
Yes, sir.
okay, yeah. So this is how we saw the mode in the case of a ungrouped data. Now, if I have a group data, that is, if I have class intervals, then we'll see how we can find out the mode. Okay, so if you take this example here, where we have classes given and frequencies are given. Okay, like classes are 0 to 10, 10 to 20, 20 to 30, and 30 to 40, and their frequencies are given. Okay, so all of you can note down this example here, classes and frequencies. Okay, so class intervals and frequencies are given. Okay. Um, Now what we do is first we'll see which interval has got the highest frequency. Okay. So as you can see here, highest frequency is 8, and that is for the interval 10 to 20. So this interval is called as our modal class. That means our mode will be somewhere within this range from 10 to 20. Okay. So that's the first thing. We see which interval has got the highest frequency. So that is 10 to 20. And once we see that, then we'll use a particular formula to find out the exact value of the mode. So there are different formulae. In fact, there are two formulae which are there. I think many of you would have used the second formula in terms of F0, F1, F2.
Yes, sir. Second one.
Okay, okay. So
Yes,
we
sir.
can Yeah. So we can use any of them. Okay, we can go by the second one. So the second formula says that mode is equal to L1 plus F1 minus F0 into L2 minus L1 upon 2F1 minus F0 minus F2. Okay, so everyone can note down this. Okay, those who have not used the formula earlier also can write down this. One second, I'll just save this one. Okay, just a minute. Yeah, sorry. Yeah, so this is the formula. L1 plus brackets F1 minus F0 into L2 minus L1 upon 2F1 minus F0 minus F2. Okay, so we have to just understand what is F0, F1, F2 here. Okay. L1 and L2 are similar to the earlier one, like how we did for median. L1 and L2 are the lower and the upper limits of this interval, 10 to 20. So L1 is 10, L2 is 20. Okay. Now here, highest frequency is 8, which is taken as F1. Okay, just a notation used. If you want, you can use any other notation also. Okay, in case if you have used some other notation earlier, you can use that also. Okay, so anything you can use here. F1 stands here for the highest frequency, 8. F0 here represents the previous frequency, 4. And F2 represents the next frequency. That means next to the highest one. That is F2, which is 3 here. Okay, so F1 is the highest one. F0 is the frequency previous to the highest frequency. And F2 is the frequency next to the highest frequency. Okay, so this is how we take these three things. And then we just put the values in this formula here. L1, again L1 is separate here, plus F1 minus F0 into L2 minus L1 is the width of the interval. Okay, so you must have used it as L or something in your formula earlier, upon 2F1 minus F0 minus F2. Okay, is this formula clear, everyone?
Yes, sir.
So, yes, sir.
Okay. So all of you can write the formula and then just substitute the values here.
14.444.
Okay, right, very good. Yeah, 14.44. Okay, so everyone can just check this. Okay, so mode is coming as 14.44. Everyone getting this value here?
Yes, sir.
Okay,
Yes,
fine. Okay, so it's very simple. We have to just be careful with substituting the values, and then we should be able to get it. So mode is coming as 14.44. Okay, so you can say this one is the most common value, which is appearing in the data. Okay, so whenever we are having a class interval data, we can find out the mode in this way. See which interval has got the highest frequency. That will give you L1, L2, and take that highest frequency as F1. The frequency previous to that, take it as F0, and the frequency next to the highest one, take it as F2, and just put the values in that formula, and we'll get the answer. Okay, so that's how we have got the mode here for a class interval data. Okay. So, so we have seen all the three important measures, that is the mean, median, and mode for ungrouped data as well as for group data. Okay. Now, these three are, you can say, the most commonly used measures, though there are other measures also which we'll be seeing, but these three are the ones which we refer to most often. Okay, and uh, okay, I'll come to this also, geometric mean. Before that, I'll just tell you about uh, if the three values are equal. Okay, just a second. I'll just, yeah. If you find that uh, if you have any data where the mean, median, and mode are all equal, then the data is called as symmetric data. Okay, suppose we have a data of marks, suppose, and we calculate the average marks, median, and mode also, and they all come out to be the same. Then we say that the data is symmetric. Symmetric data, and we can represent it as a bell-shaped curve. Okay, this is the diagram we can have. Okay, this curve is called as a bell-shaped curve. Okay, we also call it as a normal distribution curve, which we'll be seeing later when we go on to the topics of probability and distributions. So basically, it's a symmetric curve, symmetric data, a bell-shaped curve, and also called as a normal curve. Okay, so so this is how we represent our data when all values, mean, median, mode, will be equal. So as you can see in this diagram, this symbol mu is the mean value. Okay, mu represents the mean of the entire population. Just like x bar we have seen earlier, x bar will represent the average of a sample, whereas mu will represent the average of the entire population. Okay, like say our population right now is say 50 or 51 students, suppose. So if I find out the average marks, say average marks is 85. So that will be the value of mu because it is for our entire population presently. But if I take a sample of 10 students and say their average marks is 74, that we can denote as x bar. Okay, so x bar will denote the average of a sample. Okay, whereas mu will be denoting the average of the entire population. Okay, this is just a difference in the symbols which we use for population value and sample value for the average. Okay, is it clear, everyone?
Yes, sir.
Yes, sir.
Okay, okay, very good. So our mean values here. Now, at the same point, we'll also have the median also because as you can see, for this point, half the curve is on the left side and the remaining half is on the right side. So the entire curve is symmetric, or you can say equally divided around this point. So this point is also the median. And this point will also be the mode because at this point you can see we have the peak of the curve. That means frequency of the curve is the highest here. And wherever the frequency is the highest, that point is our mode. Okay, so the mean is here. We also have the median and also the mode. So all the points will coincide at this same point here. So that's why we call this data as symmetric. Okay, a bell-shaped curve. Okay, and what this data also means is that near the average value, the frequency is the highest, and near the two ends, like near the left side end or the right side end, as you can see, it's very close to touching the x-axis. Means frequency is very low. Okay, so at the two ends, the frequency is very low, and near the average, the frequency is the highest. So this means that there are more values which are near the average, and very few values at the two ends. Okay, there are more values which are near the average value, and lesser values at the two ends. Okay, like suppose we consider height. So there'll be more people whose height is closer to the average height, and there'll be much less number of people who are too short or too tall. So extreme values will be less and more values will be closer to the average. So height is one such variable which follows a symmetric data or a normal curve, a bell-shaped curve. Similarly, you can have other variables like say suppose performance scores, incomes, heights, weights, etc. These are all different variables which can follow a symmetric data. More values will be near the average and less values are at the two ends. Okay, So this is one of the important features of a symmetric data or a bell-shaped curve like this, where all the three values, mean, median, and mode are coinciding. Is this clear, everyone?
Yes, sir.
Yes, sir.
Okay, okay, okay,
Yes, sir.
Yes, sir.
okay, okay, very good. So this is what we mean by symmetric data. Now, in case if all the values are not equal, that means the mean, median, and mode are not equal, then we say that the data is a skewed data. Okay, as I'm just showing it on the screen, it is called as skewed data. Skewed means you can say another term for asymmetric data or unsymmetric data. So we call it as a skewed data, and this property is called as skewness. Okay, so skewness basically refers to the fact that mean, median, and mode are not equal, so the data is no longer symmetric. Okay, so that is called as skewness, and one very simple way of getting the skewness is mean minus the mode. Okay, that is a simple way in which we can calculate the skewness, mean minus the mode. Okay, now if mean and mode are equal, what happens is if these two are equal, you'll find that the median also will become almost equal to these two, and your data will become symmetric. Okay, so if mean and mode are equal, your skewness becomes 0, and the data will become symmetric. Okay, so this is an important concept here. First, we saw symmetric data where the three values are equal, and skewness takes place when the three values are not equal, and we can calculate as mean minus the mode. Okay, now this value of skewness can be either positive or negative, depending on whether mean is greater than the mode or mean is less than the mode. Okay, see, if you find that mean is greater than the mode, then value of skewness will be positive, and if mean is less than the mode, skewness will be negative. Okay, so we can have these two types of skewness here, positive or negative. Okay, is this clear, everyone?
Yes, sir.
Okay, okay,
Yes, sir.
okay. Yeah, okay. Now, what do we mean by this one, positive or negative skewness? See, in positive skewness, our mean value is greater than the mode. Okay, that means our average value is greater than the most common value. Okay, that is what we mean by this positive skewness. Okay, so suppose if I have a data about marks of students of a class, and if the data shows positive skewness, okay, then is the performance of the class good or bad?
Good.
The marks are following a positive skewness. That means mean is greater than the mode. Yeah, or if you can just think a little and then tell me then. Okay, suppose there is a batch and we have noted down their marks, and these marks follow positive skewness. That means mean is greater than the mode.
So it's bad.
Okay, why is it bad? Or those
Uh,
who are saying good, those who are saying good, why is it good? Both can just give the reason.
higher the skewness, higher the unsymmetricness.
Yeah, okay.
So it should be symmetric.
But suppose if it's not symmetric and it has a positive skewness. So that means in this case the mean is greater than the mode. That
Yes,
means
sir.
the average value of the marks is greater than the mode. Mode means the most common marks. Okay, I'll give an example. Suppose the average marks of a class is uh, say 70. Okay, average marks are 70, and the mode is say 65. So mean is greater than the mode here. So what it means is that uh, mode means the most common value. That means there are many students in the class who have marks of 65, the mode value, and average marks are 70. So what does it show about their performance?
most of the people have scored 65, but some guys have scored more than 80 or higher than 70, taking the average to 70.
Yeah, okay. That means there are lesser number of people who have done well, but most of the people have performed below average.
Yes.
Okay, I'll explain it again. See, the most common marks is suppose 65. Okay, like suppose in our class of 50, say there are 35 people who have got 65 marks, and the other 15 have got higher than that, and the average marks are 70. That means a majority of the class has got marks which is less than the average, less than 70. So that means that it's not a good performance overall, not a good performance overall for the class because majority of the students have performed below average. Okay, is it clear, everyone?
Yes, sir.
Yes, sir.
Okay, like say out of 50 students, if 35 have got marks less than average, that means overall the class is not done well. Only very few have done well, and because of their good performance, the average has become 70. But overall performance is not good in this case. Okay, because most of the people have got marks lesser than average. Okay, but suppose this data was about pollution levels of different cities. Okay, then it would have been good because then we can say that most of the cities have a pollution level less than the average value. Okay, then it can be considered as favorable. So it depends on what parameter we are measuring. If it is something like pollution levels or some health parameters like weight or cholesterol levels, etc., then it is good. But if it is something about performance, marks, etc., then it is not a good one. Okay, is it clear, everyone?
Yes, sir.
Okay, so this is what we mean by a data. Yeah,
Yes.
we, yeah. Any doubts, anyone?
Sir, could you please explain it once again?
Yeah. Okay, I'll just explain that. See, what I said is that positive skewness will happen if mean is greater than the mode. This is fine till here?
Yes, sir.
Yes.
Okay. Now, if mean is greater than the mode, that means our average value is higher than the most common value. Or I can say that the most common value is lesser than average. So in terms of marks, if I say that the most common performance of the class is less than average, that means many of the students in the class have performed below average, which shows that the performance of the class is not good. If majority of the people are performing below average, then it's not a good sign. Okay, so this is what we understand from this data about marks when it has a positive skewness. Okay, is it clear?
Yes, sir.
Okay, but as I said, now it depends on what you are measuring. If you are measuring something like pollution levels, then it is good. If I say that out of 50 cities taken, there are 35 cities which have a pollution level less than the average, then it is good. Okay, so depending on what parameter we are measuring, it could be either favorable or unfavorable. Like in terms of marks, it was not good, but in terms of pollution levels, it was good. Okay, a data which has a positive skewness, mean is greater than the mode. Okay, everyone clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, everyone, okay, clear?
Yes, sir.
Yes, sir.
पिक्चर चला गया
Sir has some connectivity issues. Okay?
Professor Sandeep is having connectivity issues. He's trying to join us again.
Guys, since sir is gonna join in few minutes, please mark your attendance. The link is in the chat box.
Hello. Hello. Are you able to hear me, everyone?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah.
Yes,
Sorry
sir.
for that. Sorry for that. Then when that connectivity had gone, so it took a lot of time. Really sorry for that. Okay. Okay. I think that file you're not able to see, no? One second. I'll have to. I'll just share that file again. One second. Okay, so what I was saying was about positive skewness was that if mean is greater than the mode. Hope all of you able to see the file now here.
Not yet, sir.
No, sir.
No, sir.
Not
No,
yet,
sir.
sir.
Not yet, sir.
Not yet, sir.
Okay, maybe in a minute it will come. Are you able to see now?
Yes,
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 sir.
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 Yes, sir.
Okay. So I was talking about positive skewness is when your mean is greater than the mode, and just the opposite of that is negative skewness when your mean is less than the mode. Okay. So if suppose we have a data of performance of students, and if I say that the data has got a negative skewness, it means that the mean is less than the mode. That means the average marks is less than the most common marks. Okay. So in that case, it will be showing a good performance because there are many students in the class who have got marks higher than the average. So that shows it's a good performance. Okay, exactly opposite of positive skewness. Okay, but in terms of pollution levels, it will be bad because if there are many cities which have pollution higher than the average value, then it will be bad. Okay, so these are the two types of skewness we can have: positive and negative skewness. Okay, is this clear, everyone?
Yes, sir.
Okay. Now, okay, don't worry about this formula for coefficient of skewness. Don't worry about that. Standard deviation we'll see later. Okay, you can just see this last one, that if you have a moderately symmetric data, then mode can be calculated like this. Okay, that means moderately symmetric means that if your if mean, median, and mode are not exactly equal, but they are somewhat close to each other, then we can find out the mode from this formula. Mode is equal to 3 median minus 2 mean. Okay, so all of you can note down this also. This can also be used in cases where there is no particular value which is repeating more often. Okay, if I don't get a mode directly because there is no most common value, then if a mode is required to be found, then we can get like this. Mode is equal to 3 median minus 2 mean. Okay, so this is one formula we can take here. For moderately symmetric data, we can have this. Okay, mode is equal to 3 median minus 2 mean. Okay, everyone done till here?
Yes, sir.
Okay, yeah, fine. So and then skewness we know na, we saw it mean minus mode. So we can write mean minus mode is nothing but 3 median minus 2 mean. So I've just substituted it here. And so skewness can be also written as 3 times of mean minus median. So that's another formula for writing the skewness. 3 times of mean minus the median. So either we can have it as mean minus mode, or we can have it as 3 times of mean minus median. Okay. So in measures of central tendency, we saw mean, arithmetic mean first, weighted average, then median, then we saw the mode, and then if all the three are equal, we saw that the data is symmetric data, which is shown by a bell-shaped curve. Okay, and if the values are not equal, then we say that it's a skewed data, and that property is called as skewness, which we can measure it as either mean minus the mode, or we can also write it as 3 times of mean minus median. And skewness can be either positive or negative depending on whether mean is greater than the mode or less than the mode. Okay, is this part clear, everyone?
Yes, sir.
Okay, okay.
Yes, sir.
Yes, sir.
So, okay, fine, fine. So for
Yes,
the,
sir.
yeah, okay, good, good. So for the foundation course test, we'll have it till here. Okay, so whatever we have covered in these 4 sessions till now, we'll have it till here. Okay, so anyone has any doubts in this part here?
No, no, sir.
Okay,
No.
so it'll be very, okay, so it'll be very simple one. Okay, nothing to worry about. Very, very, very basic things like we have done here. Okay, so it'll be for 20 marks and like very simple one, like less than half an
Sir,
hour. You'll be able to finish it very fast. Yeah.
sir, there will be theoretical questions, or we will have to solve some sums and get the answers.
There'll be yeah, there'll be some like all everything will be in the form of MCQs, wherein yeah some will be theory and a few will be simple problems.
Okay, sir.
Like yeah, but everything will be very very easy. Nothing to worry about.
Acha, okay.
So total marks will be 20. Some questions will be like 1 mark and few ones will be 2 marks. So
And
total will
test
be
is
20
on
marks.
27, sir?
Yeah, yeah, yeah. 27. That is Wednesday. Yeah. So
Okay.
Wednesday morning we can have it say at 9:30. So on Tuesday I'll send you the link for that. Okay, and on Wednesday, once you open that, once you come to the meet, then just go to assignments under Teams. Once you go to assignments, then at that time 9:30 I'll assign that. It'll be shown as a quiz. So I'll be assigning the quiz, and then under assignments you'll be able to see this quiz. Okay, the time etc will be mentioned like say 9:30 to say 9:45 or something. It will be a very very simple one. So I'll mention the time. So within that time, you'll be answering that, and you have to just once you complete everything, you have to just submit. Just like you have a Google Docs form, na? Same way here also. Once you once you put all the answers at the end, just once you submit it, uh, the answers will go. Okay.
Okay, sir.
So in Google, like there it is called as a Google form. Here it is a MS Teams form as a quiz, and it will be shown under assignments as a quiz. Okay, so Wednesday 9:30 we'll have this, and on Tuesday I'll send you the link for this meeting also. Okay, any other questions, anyone?
No, no, sir.
Okay, okay, okay. So it will be a simple one, nothing to worry. Okay, and then once your tests are over Wednesday, Thursday, then the lectures from Friday, then we'll see when our lectures will be there. So then we'll continue from this part then. Okay. So, so
Okay,
these are
sir.
the things we'll have till here.